Hey guys, let me just share my screen and we can get started. Okay, hi, I'm Lisa, for anyone who wasn't here at the last lecture on Tuesday, and I'm gonna be talking to you today about trimming data and further quality controlling. I'm gonna apologize in advance. My dog is drinking out of his water bowl right now, and sorry, is there no sound right now? Can you not hear me? Okay. Sounds good. Yeah, I'll apologize in advance. My dog is definitely going to be making noises throughout this lecture, so just be aware. Okay, so let me just get started here. Okay, so just like last time, the slides are up on the course website, so if you want to follow along, they're there for you. I put some code in the slides again if you wanted to copy it over to your personal files and whatnot. So today I'm going to be talking about trimming data and quality control. So the last class on Tuesday, we talked about how to download data that's publicly available from the sequence read session. I don't remember what it's called, the SRA website, and then how to quality control. And then today we're going to be talking about trimming and further quality control. So why do we need to trim our data? So most importantly, we want to get rid of adapters and low quality bases, right? So like we've talked about before, particularly in our paired end data, but I believe single end also uses adapters. We want to get rid of any kind of any primers, adapters that were used in the sequencing process. And then any kind of bases that are considered low quality. So I believe Dan talked about this a couple weeks ago. There are quality Fred scores for base calling. And I'll go over that in, I think, the next slide, but you want to eliminate base calls that were deemed low quality. And yeah, this is a really important pre-alignment step. Specifically for SNV detection and de novo assemblies, you want to get rid of those low quality base calls to keep it accurate, I guess. So some of the tools that are currently available, trim Galore plus something called cut adapt. It's super common. It's available on Big Purple. You can use it as a command line tool like we've used like FastQC and stuff. Trim-O-Matic is another tool that I've used. The FastX toolkit I've not used, but it is available. These are just a couple things that have been shared with me. But today I'm going to focus on just Trim Galore. It's something that I've used in many classes and for my personal projects. It's a pretty easy tool to use. They have pretty good documentation on their website. It uses something called Cut Adapt, which was just a program. I believe it's either written in Python or requires Python. So you just need to load Python when running this. But we can go to the documentation that I have open. Here it is. This is their GitHub page. Yeah, so let's go to all the flags. So yeah, so in general, most of these command line applications will have manuals that kind of look like this, where they show you all of their flags that you can use for their program. -H or -help is kind of universal. Usually works with any command line program to get help on all of the different commands you can use. But this -Q is really important. It's the default Fred score for, or the custom Fred score, I guess, that you want to tell the program to basically get rid of any kind of filtering that it should do for low quality scores. So the default is 20. And as Dan talked about 2 weeks ago, the Fred score is calculated with this equation here. And a Fred score of 20, for example, means that there's a 1 in 100 chance that the probability of the base call is incorrect, or basically it's a 99% accuracy base call. For most of the trimming that I've done, I've used a Fred score cutoff of 30. It's a 99.9% accuracy. You can use your own judgment pretty much. And I mean, you can increase it to like 60 here and have even more base call accuracy. I mean, you're probably gonna get rid of some stuff that might be important in your sequencing. But yeah, generally 20 to 30 is kind of like a standard cutoff that's used. Go back to the manual for Trim Galore. Fred 33, that's usually the general, I think it's like the, yeah, it's the code, yeah, the encoding that the cut adapt has to find within your base calling. It's usually the default. I generally don't specify it unless I know my sequencing data was used with Fred 64. But yeah, if you don't specify this, it just assumes Fred 33. It has a fastqc flag, so after it trims your file, you can tell it to run fastqc, and you can get those same outputs that we had on Tuesday, and just visualize as, again, like what happened after trimming. Did it get rid of any adapters that were there before? What does your file look like? Is it ready for alignment? This fastqc args, I think you can just tell it where to output a fastqc file if you're doing it. It has these custom adapter commands here that are flags that you can add. So if you don't specify it, I believe it does have auto detection, but you can specify if you have custom adapters or something. You can tell it if it's Illumina data, Nextera, small RNA. Again, it should be able to auto detect, especially for Illumina data. Let's see if there's anything else that's important. There's a lot of flags that you can use. gzip, I usually use that so that it zips the file, again, similar to how we downloaded. It's a zip file, it's just taking up less space. Yeah, and there's a lot of default, so you can all look through this in more detail. There's a lot of defaults that are kind of just already set that you can change. If you don't specify them, then the program will just assume the default that it's told. I think that's all that I wanted to say for that. Okay. Oh, and then this -o is kind of commonly used as like the output directory. So you put -o and then the path to wherever you want your output to go. I'll show you that in our little demo that we'll do. And this -- paired, I'm telling the Trim Galore command that it's paired data. So I'm using the same files that I used last time, and can go over that again in the demo that we do. So this was the download example script from the last lecture. If you want to run this, you can copy this from the slides. Just make sure you change the email over here. We can go through this again to remind everyone. So the top job name is just the download example job name that I gave it. If there's any failure or when the script ends, it'll email me. Put your email here. I'm giving it 1 CPU to run on, 8 GB of memory. This is 2 hours of time to run. And then this is the path for my log file output. And then I'm telling it the partition should be CPU short. Yes, so this was the downloading step and the QC step. And then this is my trimming script that I already ran. You guys can also run this in your home directory. Just make sure you submit it as a job. So for example, if you go into Nano, copy and paste this into your Nano as like a new file, or Vim, whichever text editor you want to use. Save this as a .sh script, so it's a shell script. And then just make sure all the paths are written correctly, right? So you're telling the program exactly where to go and where to find these files, which if you use the downloading script, you'll download the files, put them in somewhere in your home directory, then tell it where to find those files here so that it'll be able to trim them and output them somewhere else in your home directory. Just make sure if you're going into the class directory on Big Purple. Unfortunately, I don't think we have a class directory yet in Prince. I'm sorry for the holdup on that. But if you go into the class directory in Big Purple, just don't change any of the files there. I think I did change the permissions now so that only I can change the files, but you should be able to copy them if you want to copy them. Yes, so this is the example trim galore script that I've already run, and I'll show you guys the outputs. So I'm loading the trim galore module here. As I said before, it does depend on, it has a Python dependency in the cut adapt script, so I had to load that. I also loaded fastqc. I'm actually not entirely sure you have to load fastqc. I should have looked into that. It might have already, trim galore might already have that, but I loaded it just in case. And then this is the example trim galore command that I ran. So you start off with the first line is trim galore. I told it that it's paired data. I want the Fred cutoff to be 30, the quality score. I want it to gzip the new files that it makes. I want it to run fastqc after trimming. This is the path to the first file, which is just the first read, and then this is the path to the second one, so it's the forward and reverse. And then my output here is just a folder that I named trimmed files. And then since I'm not specifying a place for the fastqc files to go, they're also going to go into here. But you can tell it with the command fastqc args that we saw in the documentation where to put qc files if you want them to be somewhere separate. And then I just wanted to show you guys an example. If you wanted to run all of this together, the downloading step, the initial QC, and then the trimming step, you can put it all in one script, name this whatever you want. So I don't know, test.sh, and then sbatch your file name, enter, that'll submit the job, and you can just run this all in one script, essentially. So after we're done trimming, what do we do? So now you can look at your post-trimmed QC reports. Do we see that our adapters are removed, our low quality base is removed, and if they're not, you might have to retrim with some sort of custom adapter file or something, use a different type of trimming module like Trimmatic or the FastX tools. But for now, I'll show you my little demo with, let me just, might have to relog in here. So if everyone wants to follow along, you can SSH into Big Purple. Okay, so now we're in the class page. This folder, I renamed it to just download QC trim. So I'm gonna go into that folder, and I have two scripts here. One is titled download example. That's just the one that we looked at last time. So I can show you that again. Here it is. I just nanoed it. It's all the same. To exit nano, you just do Control-C on a Mac. I don't know if it's different on a Windows computer. And then this is the trimming script that I have. Again, similar to what I just showed you. I have all the flags here, modules loaded here. And to run that, I would just do sbatch trim.sh. I'm not going to enter now because I don't want it to overwrite the files that I already have, but that's essentially all you have to do to submit that as a job. Let me just make this larger. Okay. So if I go into my downloads file. Yep.
I'm sorry. Can you unlock the folder for download QC trim? I think you still have. It's the permissions aren't open for that folder.
I see. Sorry about that. Hold on. Okay. Okay. I'm just gonna make it available. Just don't overwrite anything in this folder. And also please change the email to your email. I don't want to get 1,000 emails. Oh, actually, I might have to do, okay. You guys should be able to get it now. Sorry about that. Okay. So now if I go into downloads, we'll see these are the sequencing files that I had gotten from SRA. I moved the QC folder here just because it's taking up space. The original QC is in this folder. Then I have my trimmed files folder. So that has the output after I ran trim galore. So, okay. When trim galore outputs a FASTQ file, you'll see this val here. I believe that's just validation that it matched the original file. But we can look at this trimming report that it outputs as well. So this is what the trim report output looks like that it gives you. It tells you which file it's looking at. It tells you which trimming mode. So this was paired end. Cut adapt is tells you the version. The quality Fred score cutoff that I told it was 30. It's Fred 33. It recognized, auto-detected this adapter sequence immediately. It knows that it's an Illumina TrueSeq sequence. Let's keep scrolling through it. Yes, so it's giving you some stats for the trimming. You can keep scrolling. Hold on. Yeah, so that's pretty much it. And then if you look at the log file, I believe it has more, it has that information plus a few other things. Yes. So similar information here in the log file. Yeah. And then this is the FastQC part of the analysis that it's running. Yes, okay, writing validated paired end reads. So that's just what this file, it's basically saying that this file has been validated after the trimming. So then we can go, if I go back to my trimmed folder, I'll see this HTML here again. That's the FastQC report post-trimming. So I can just move that onto my computer. Again, you can use SCP, it's secure copy, I believe. Or if you download the FileZilla application or any other file transfer applications, this is the only one that I'm aware of or that I've used. But it looks like this. I'll just remind everyone. So it can connect you to Big Purple, and you can do this for prints as well, or really any other cluster that you can SSH into. Okay. So yeah, so you can move these files over to your local computer. I've already done that. There are these two right here. So then now we can visualize them. Sorry, my dog is being very needy right now. Okay, so you can open the HTML files in your web browser. So this is what the FastQC of the original data, the raw data, looks like. So this was the first run, and I think I showed you guys this last time, so I'm not going to go into any detail, but then this was the QC file for the post-trimmed data. So originally when I looked at this, I was like a little confused as to why there were still a lot of flags for the QC, but this data was transfected with virus, so it's going to have some flags show up because the program does not know that this is viral. There's viral RNA in this. If it was just human, it would not be showing as many flags, but it's just because it's not understanding that there's like a bunch of like overrepresented sequences and stuff. But the one thing that was different, I believe, was that the adapter should be gone. So the adapter content did originally look fine. There was this little like uptick here. If we look at the trimmed one, it's gone. So something was removed. If you look at just the number of total sequences, it is smaller in the post-trimmed one. So this is pre-trimming. This is post-trimming. But yeah, there's still a few things that are flagged here. The GC content isn't going to be good because, again, there's viral RNA in this particular experiment. There's a lot of overrepresented sequences. So that's just the program in its default settings. I did want to show you an example of some human data that I personally worked with. This was some low-pass genome sequencing that I ran for a separate project using I believe it was in the NYU core where this data is coming from. But these are human cells that we did some genome sequencing on. So this was the QC before trimming. There were some sequences here that were tagged as TrueSeq adapters. And then after I trimmed it, that was gone. Pretty much everything else stayed the same. I believe there were sequences cut out. So this is the pre-trim again. This is the post-trim. So did get rid of some reads there. And that's pretty much it. So if you wanted to say rerun trim Galore, you can give it some more extra like parameters or more stringent commands to kind of get rid of some of those sequences that you wouldn't want. It really depends on the experiment. Yeah, that's pretty much it for that. I'm just gonna check the chat real quick. Sorry. Okay. For the Python module, I think Tosh addressed that. Yeah, it really depends on what your HPC has. I know this particular module works with cut adapt, but I think Python 3 should be fine. All right, I think there's no other questions. That's pretty much it for today. I know that was like super quick, but this is a pretty simple task. If you want to run these scripts yourself to obtain this data, especially for people who don't have Big Purple, that's available here in this combined download plus trim script. So again, just copy this into a text editor that you're using in your HPC. Could be Nano, it could be Vim. Save it as a .sh file and then sbatch that file name to run it as a job, pretty much. You can srun, so create an interactive node. However, some of these steps might take a while. So if you're in interactive mode and say you start like downloading the data or something, it's just going to be like the line is just going to stay blinking and you won't be able to do anything else. And it might take like quite a bit of time since it's a lot of data. So I would recommend submitting it as a job. And then, yeah, if anybody has any questions, that might have been a little fast, but this is a pretty simple task. What is the correct input for the trim.sh? So your input into the trimming file should be your original FASTQ files. It should not be the QC file. You want to give it the raw data because the trimming step is cutting any kind of unwanted sequences from your raw data. Do you make a separate folder for trimmed files? You can, it's like really up to you. I did, I had, let's see, I can go back. Yeah, so I created this folder for the trimmed files plus the FastQC on the trimmed files, just so that I knew which files were trimmed and which aren't. My original files are in my folder called downloads. Yeah, that's really up to you, however you want to organize it. If there's any other questions, feel free to ask now. You can ask in the Slack channel or on Stack Overflow if you want to try these out yourselves. Big Purple seems to be working much better today. I know there was some issues on Tuesday. It was a little backed up, I think. All right, if there's no more questions, I think we can end a little early today. Thank you guys so much for sticking around with this course. Been trying really hard to make it happen while everyone's still home. So yeah, thanks so much. And again, if you have any other questions, I'll stick around for a bit. Tosh and I are here. I believe Fred is also here to answer any questions.